So in today's video, we'll be discussing about Mathematics Paper 4 Mechanics 2024 May-June, variant is 41 and the subject code is 9709. The solved PDF link and the timestamps are provided in the description, and also there is a video that how to download the solved PDF, and also it is recommended that to watch this video in high picture quality. Number 1. A car starts from rest. So since it starts from rest, so initially the velocity is 0 and accelerates at 2 meter per second square. So the acceleration is 2 meter per second square for 10 seconds. So for 10 seconds the acceleration is 2 meter per second square. It then travels at a constant speed for 30 seconds. So for 30 seconds it travels at a constant speed. So for 30 seconds it travels for a constant speed. The car then uniformly decelerates to rest over a period of 20 seconds. So over a period of 20 seconds the car decelerates to rest. Sketch a velocity time graph for the motion of the car. So the velocity on the y-axis and the time on the x-axis. So initially it starts from rest, accelerates for 10 seconds, then constant speed for 30 seconds, then decelerates for 20 seconds. So 10, 10 plus 30, 40, and 40 plus 20, 60. So velocity against time graph. Find the total distance traveled by the car. So what is the total distance? So first of all, the distance for this area So first of all, we have given the value of acceleration and the value of time. So we know the acceleration and the time. So what is the velocity? So acceleration is equal to velocity by time. So velocity is equal to acceleration in time. So acceleration 2 into time, that is 10. So this is the velocity. This is the topmost velocity. That is 20 meter per second. Now we know the velocity. Now we can calculate the total distance by calculating the area under the velocity time graph. Because the area under the velocity time graph is the total distance or the total displacement. So that is the area of the trapezium, that is half into sum of two parallel sides, that is this parallel side, that is 60, and this parallel side, that is 40 minus 10, that is 30. So 60 plus 30, half into sum of two parallel sides into height, and the vertical height is 20, that is 20 meter per second. So after calculating, we get a distance or the total displacement as 900 meter. Two forces of magnitude 20 Newton and F Newton act at a point P in the directions shown in the diagram. So this is the point P and the two forces are acting. There is F Newton and 20 Newton. Given that the resultant force has no component in the y direction. So the resultant force has no component on the y direction means that the resultant force on the y-axis is 0. That means the resultant force on the force on the upward direction is equal to the force on the down. So upward force consists of the down force and the resultant force on the y-axis is 0. Calculate the value of F. So we need to find the value of F, that is a downward force. So we know that the resultant force in the y-axis is 0. That means the upward force is equal to the downward force. So downward force is F and the upward force. So we need to break the 20 into its component. That is 20 cos 60 and 20 sin 60. So 20 sin 60 is equal to F. So the value of F comes to be 17.3 Newton. Question number 2, part B. So given instead that F is equal to 10, find the magnitude and the direction of the resultant force. So we have given that the value of F is 10. Now what is the direction and magnitude of the resultant force? So resultant force. So for the resultant force, first of all, we need to find the resultant force on the y direction, that is on the y direction and on the x direction. So resultant force on the y direction, that is, if we consider the upward as positive, then 20 sin 60 minus 10. So 20 sin 60 minus 10, that is this value in the upward direction. And if we consider the right as positive, then 20 cos 60. That is, the resultant force on the x-axis is 20 cos 60. So 20 cos 60, that is 10 Newton, that is in this direction. So the resultant force is in this and this direction, that is in this direction. So what is the resultant force? So since the resultant force is the hypotenuse of the right angle triangle, so we can use the formula, that is r square is equal to rx square plus ry square. So by using this formula, we calculate the resultant force, that is 12.39 or approximately 12.4 Newton. Correct to three significant figures. Then we know the value of resultant force. Now what is the, so we have found the magnitude. Now what is the duration of the resultant force? So we need to find the angle, that is the x value is 10 and the y value is 7.332. So by using the formula, that is tan alpha is equal to opposite by hypotenuse, tan alpha is equal to opposite adjacent, sin alpha is equal to opposite by hypotenuse, cos alpha is equal to adjacent by hypotenuse. So tan alpha would be opposite by adjacent. So opposite by adjacent, by using the formula, we calculate the value of alpha. Then we know the value of alpha. Now that means the angle, and so we know the value of angle, but we need to state the direction clearly. That means this much angle above the x-axis, that is above this x-axis. Then this much angle, or this much angle anticlockwise from x-axis. So from x-axis, the movement of the angle is anticlockwise. That is 36.2 degree, or 36.2 above the horizontal. So this is horizontal and this angle is above the horizontal. So you have to write either of this from these three. You have to write any one for your answer. That is to state the direction. That is 36.2 degree above the x-axis, or above the horizontal, or anticlockwise from x-axis. So this direction is anticlockwise. In question number 3, a train of mass given ascends a straight hill of length 1.5 km inclined at an angle of 1.5 degree to the horizontal. So the angle is 1.5 degree and the length of the hill is 1.5 km or 1500 meter. That is the length of the hill. And the train ascends the hill. That means the train is moving upward. So this is the length, that means the total length of the hill. And since the train ascends, that means it is moving upward. So as it ascends the hill, the total work done to overcome the resistance to motion is given. So this is the work done against the resistance, that is WR. And the speed of the train decreases from 45 meter per second to 40 meter per second. So the speed decreases from the bottom to the top. Find the work done by the engine of the train as it ascends the hill, giving your answer in kilojoule. So we need to find the work done by the engine or the work done by driving force. So work done by engine or work done by driving force. So we know we can use the before and after. That is, before, that means at the bottom point. What is the kinetic energy? Kinetic energy is equal to half m, that is the mass, and v square. So half mv square, that is the initial kinetic energy and initial gravitational potential energy. So at the bottom point, since it is at the bottom point, so the gravitational potential energy is 0 since the vertical height is 0, as gravitational potential energy is equal to mass into gravitational force into height, and since it is at the bottom point, so the vertical height is 0, so the gravitational potential energy is 0, and we need to find the work done by driving force. And at the topmost point, so what is the kinetic energy? We have given the speed. So by using the speed, kinetic energy is equal to half mv square. So kinetic energy and gravitational potential energy. So what is the value of gravitational potential energy? So we know the length of the hill, that is 1500 meter, and we know that this angle is 1.5. 1.5. So what is the vertical height? So sine 1.5 is equal to height by 1500. So h is equal to, so the height comes to 39.26. That is the vertical height. So gravitational potential energy is mass into gravitational force into height, and the gravitational force is 10. So we know the gravitational potential energy. And what is the work done against resistance? So work done against resistance. So for this train, there we have given the value of work done against resistance, that is this value, and since it is in kilojoule, so we need to multiply with 10 to the power 3 to convert it to joules. Then we know the kinetic energy, gravitational potential energy, and work done by driving force before. and after kinetic energy, gravitational potential energy, and work done against resistance. So before is equal to after, that is we equate these values and find the work done by driving force as given. And we need to express this answer in three significant figures. So 1, 2, 3. So 3 SF. And the answer is in kilojoule as given in the question. Question number 4. A car of mass 1700 kg, that is, we have given the mass of the car, is pulling a trailer of mass 300 kg. So we know the mass of the trailer along a straight horizontal road. So the car is pulling a trailer. The car and the trailer are connected by a light inextensible string which is parallel to the road. So the string is parallel to the road. And what is the tension on the string? So tension force acts away from the point of observation. So if we consider the car as the point of observation, the tension force acts away from the point of observation. And if we consider the trailer as the point of observation, then tension force acts away from the point of observation. That is away from the point of observation. That is like this. So we know the tension, that is the direction of the tension. There are constant resistance to motion of 400 Newton on the car and 150 Newton on the trailer. So suppose the system is moving to the right, so the resistive force acts in this direction, that is 400 Newton on the car and 150 Newton on the trailer. The power of the car's engine is given. So we know the value of power. Find the acceleration, that is A, of the car and the tension in the cable when the speed is 20 meters per second. So we have given the value of speed and we know the power. So by using power and speed, we can easily calculate the driving force. That is, power is equal to force into velocity. So force is equal to power by velocity. So this is the force. Then that is the forward force. Now for the car, the forward driving force, that is DF, that is this value. Driving force minus resistive force, that is the forward force minus the backward force, is equal to mass into acceleration. So forward force is the driving force, that is 700, minus tension minus 400, since both are acting in the opposite direction, is equal to mass. So mass of the car and acceleration. So this is the first equation. Then for the trailer, so forward force is the tension force. For the trailer, the forward force is the tension force minus 150 is equal to mass of the trailer into acceleration. So we get the two equations. Then we equate the value of t and find the acceleration as 0.075 meter per second square. So we know the value of acceleration. Now we can substitute the value of acceleration in any of these equations to find the value of tension, that is 172.5 Newton. Question number 5. A straight slope of length 60 meter. So the length of the slope is 60 meter. Inclined at an angle of 12 degree to the horizontal. So with the horizontal, the angle is 12 degree. A bobsled. A bobsled starts at the top of the slope with a speed of 5 meters per second. The bobsled slides directly down the slope. That means the bobsled is moving downward, or the ball is moving downward. It is given that there is no resistance to the bobsled's motion. So there is no resistance. That means there is no resistive force. Find its speed when it reaches the bottom of the slope. So we need to find the speed when it reaches the bottom of the slope. So first of all, since we need to find the value of speed, so we can use any of this equation. So we know the value of distance, that is the value of distance. So there is no distance. Then we know the initial speed. So initial speed and initial speed, but we don't know the value of time, therefore it is wrong. And we can use this equation, that is v square minus u square is equal to 2as, where we need to find the value of v. And first of all, we need to find acceleration. So what is the value of acceleration? Since the object is moving downward, so forward force minus backward force is equal to mass into acceleration. So forward force is the downward component of weight, that is the weight is acting vertically downward, that is mg. Since the weight is acting vertically downward, so the vertical component of weight and the horizontal component of weight with respective to the surface and this angle is 12 degree. So mg sine 12, the opposite side, and the adjacent is cos. So this is the forward force that is in the horizontal direction, and there is no backward resistive force or any other forces, is equal to mass into acceleration. So mass and mass cancels, and we get the value of acceleration as given. Since we know the value of acceleration, so we can substitute the value in this equation to find the value of v. So v square is equal to 2as plus u square. So 2a, and the distance is given as 60. So 2as plus u square, where we know the value of u as 5. So 5 square. So 5 square. So we get the value of v as 16.567, or approximately 16.6 to 3 SF. In question number 5, so we have done with part A. Now for part B, it is given instead that the coefficient of friction between the bobsled and the slope is 0.03. So coefficient of friction, that means the value of mu, is 0.03. Find the time it takes for the bobsled to reach the bottom of the slope. So we need to find the time to reach the bottom. So first of all, what is the frictional force? Frictional force is equal to mu r. So mu r, so we can substitute the value of mu in this equation. And what is the value of r? R is the normal reaction force. So the vertical component of weight is acting downward, so r is acting vertically upward. So we can see that r is equal to mg cos 12, and there are no other vertical forces. So r is equal to mg cos 12, that is mg cos 12 into 0.03. So we get the frictional force. Now since we know the value of frictional force, and you have to remember that we get the frictional force in terms of m, because here we have not given the mass of the bobsled, and we need to find the value of time. So what is the value of time? So we can use any of this equation, that is v square minus u square is equal to 2s, v is equal to u plus at, s is equal to ut plus half at square. But you have to remember that now for this condition we have friction, and initially for question A there is no friction, so we have to avoid all the answers from this part because there is no friction. But now we have a friction. So for friction, we know the value of initial speed. So initial speed, that is the value of u, and the value of u. Then we need to find the value of time. So there is no time in this equation, and there is time in this two equation. Then for the, so we also know the value of distance. So distance is 60. So s is 60, and just we need to find the acceleration, and we don't know the value of v. We know the value of v in this part, but since this part is without friction, but we need to find a value that is with friction, therefore we have to avoid this part in this calculation. So by using the equation we can find the time. So we need to use this equation, and so first of all we need to find the acceleration, that is the forward force minus the backward force is equal to mass into acceleration. So what is the value of forward force? The forward force is in the forward direction, that is this force mg sine 12 minus the resistive force. So mg sine 12 minus mu r, that is the resistive force that is acting backwards. So minus mu r is equal to mass into acceleration. So is equal to mass into acceleration. So mass and mass cancels, and the acceleration comes to be 1.785 meter per second square. So we know the value of acceleration, so we substitute the value, and we know the value of distance, that is 60, and initial speed, that is 5. So we know the value of distance, that is the total length is 60, and the initial speed is 5 meter per second. Then we substitute the values in this equation, and we use the formula x is equal to minus b plus minus root over b square minus 4ac by 2a. So by using this formula, we find the value of 2 times, and since time cannot be negative, so it is inadmissible, or unacceptable, or this is the wrong answer, and the correct answer is 5.86. That is our final answer. Question number 6. A particle moves in a straight line starting from a point O. The velocity of the particle at time t seconds after leaving O is v meter per second, it is given that v is equal to this expression where k is a positive constant. The maximum velocity of the particle is 4.5 meter per second. So we have given the value of maximum velocity and we know the expression for velocity. Show that the k is equal to 10. So we need to find the value of k as 10. And we have given the value of maximum velocity. So we know that for maximum or minimum velocity, dv by dt is equal to 0. So for maximum or minimum velocity, dv by dt is equal to 0. So first of all, we need to find dv by dt. That is, dv by dt is equal to, so 1 by 2 comes from, then kt, and the power is subtracted by 1. That is negative 0.5 minus, so t to the power 1, so 1 comes from, and the power is subtracted from 1. That is 1 minus 1 is 0. So there is no t left. And since there is no t, so if we differentiate, it would be 0. That is 8 would be 0. Then this is our expression. And now if we just simplify, then half k t to the power negative 0.5 minus 2, and at maximum velocity, so at maximum velocity, dv by dt is equal to 0. That means dv by dt is acceleration. So that means acceleration is equal to 0. So acceleration is equal to 0. That means dv by dt is equal to 0. That is, this expression is 0. So after calculating, we get the value of k, that is in this format, there is 4 t to the power 0.5. Now we know this expression. Now we can substitute the value of k in the given expression. So we can substitute this value of k in the given expression, that is this value of k, and also we know the velocity, so we can substitute the value of velocity in this equation, and after solving we get the value of time as 6.2 seconds. Now since 6.25, so this is 5, so 6.25 seconds, that is 6.25. Since we know the value of time, so we can then substitute the value of time in the value of k to find the value of k as 10. And we need to show, that's why we have to write SHOWN shown. That is, k is equal to 10. Then for question number 6, part B. So B1, that is, verify v is equal to 0 when t is equal to 1 and 2 is equal to 16. So we know the expression for v, that is this expression. Now in this expression of v, we can substitute the value of k, that is the value of 10, in this expression, and find the value of t in terms of t without k. So we can substitute the value of 10 and find v in terms of t. Then we know the expression for v in terms of t. Now we can substitute the value of t, that is 1, and t, that is 16, in the expression of v, and find that v is equal to 0 for both these values. So we have verified this. In question number 6b, part 2, find the distance traveled by the particle in the first 16 seconds. So we need to find the distance in the first 16 seconds. So we know the expression for v in terms of k and t. So we can substitute the value of k, that is this is k, in the expression, and we know the value of k, that is the value of k is 10. So the value of k is 10. So we can substitute the value of k in the expression for v to express v in terms of t. Now we know the expression for v in terms of t. Now what is the total distance traveled? So what is the total distance traveled? So first of all, to find the displacement, we need to integrate velocity. So integrating velocity, so 10t to the power 1 by 2, so power plus 1 by power minus 2t power plus 1 by power minus 8t plus c, where c is the extra constant. Now we need to find the total distance traveled. So what is the total distance traveled? So for the total distance traveled, so if we just have to calculate the displacement, so we can calculate from 0 to 16 seconds. But since we need to find the total distance, so for total distance, you have to remember that the velocity becomes 0 at time t is equal to 1, and the velocity becomes 0 at time t is equal to 16. So since the velocity becomes 0, so we need to calculate this separately. That is, from time t is equal to 0 to time t is equal to 1, and from time t is equal to 1 to time t is equal to 16. So by using these times, we need to calculate the separate distance values or the displacement values. From time t is equal to 0 to time t is equal to 1, so s is equal to, we have to put the limit, and since we know the value of limit, so c would automatically cancels. So after substituting the limit, that is the our 1 and 0, we get the displacement as negative 7 by 3. And for the second part, that is from 1 to 16 seconds, since the velocity becomes 0, so from 1 to 16 seconds, we substitute the value of time and calculate the displacement as 45 meter. So what is the total distance? So since they are the displacement, so the displacement can be negative, but the distance values are always positive. So we have to take the positive value of this value plus positive value of this value. So this is the total distance. So we get the total distance and we need to calculate this separately since the velocity becomes 0. Question number 7. A particle P of mass 0.2 kg, so we have given the value of mass, is projected vertically upward from the horizontal ground with a speed of 25 meters per second. So initially it has a speed of 25 meters per second. Show that the speed of the particle when it reaches 20 meters above the ground is 15 meters per second. So when it reaches 20 meters above the ground, so 20 meters, we need to show that it has a speed of 15 meters per second. So we need to find the final speed. So we can use any of this equation. So v square minus u square is equal to 2as, and so we need to find the final value of v, and we know the initial velocity, that is 25 meters per second, and 2a. So s, we know the value of distance, that is 20 meter, or the displacement, that is 20 meter. And what is the value of acceleration? Since the particle is moving upward, so we have to take a negative acceleration, and if the object is moving downward, then we have to take a positive acceleration, because when the particle is moving upward, it would come to a point that it would come to instantaneous rest, and after becoming instantaneous rest, it would move down. So since we can see that the velocity decreases, so the acceleration would be negative. But for a particle that is moving downward, it would obviously keep moving downward, and it would not slow down until there is air resistance. So avoiding air resistance, we can see that the velocity would remains, or the velocity increases. But here we can see that the velocity decreases for the upward motion. Since the velocity decreases, so we have to take negative acceleration for upward. And you have to remember this, that for movement upward, the acceleration would be negative, and for the movement downward, the acceleration would be positive. So since the ball is moving upward, so the acceleration would be negative. So after substituting the value, we get the velocity as 15 meters per second, and we have to show this, that 15 meters per second. In part A, we can see that the particle P is moving upward, and it would move upward, and the height is given as 20 meter. So P is moving upward with a speed of 25 meters per second. So P is from this point is moving upward with a speed of 25 meters per second, and at this point, that means at the topmost point, or at 20 meter, it has a speed of 50 meters per second. So 50 meters per second. Now, when P reaches 20 meters above the ground, it collides with the second particle Q of mass 0.1 kg, which is moving downward at 20 meters per second. So Q is moving downward at 20 meters per second, and this occurs at the 20th height. That means above 20 meters. P is brought to instantaneous rest in the collision. So while they collide, P comes to rest. That means the velocity of P is 0. Find the velocity of Q immediately after collision. So we can use the change in momentum. So momentum before collision. So before collision, P is moving upward. So before collision, P is moving upward. So we know the velocity of P, and we know the mass of P, that is 0.2. So mass into velocity of P plus, and initially Q is moving downward. So if you consider the velocity as upward is positive, then Q is moving down. We assume that the velocity upward is positive. So since we assume that the velocity upward is positive, so the velocity downward is negative. So downward is negative velocity, and we know the mass of Q, that is mass into velocity of Q. So this is for the initial, that is before collision. And after collision, P comes to rest. So mass into velocity, and since P comes to rest, so the velocity of P is 0 plus mass into velocity of Q. And we need to find the final velocity, that is the velocity of Q after collision. So the velocity of Q comes to 10 meters per second, and since the value of positive, so we assume that the positive is for upward movement. So since the value is positive, so we can say that it is moving upward. So When P reaches the ground, it rebounds back directly upward with half the speed it had immediately before hitting the ground. Find the height above the ground at which P and Q next collide. So, when P reaches the ground, that means P from this point reaches the ground. When P reaches the ground, it rebounds back. So, it rebounds, that means it again moves upward. So, it again moves upward. So, it rebounds back directly upward with half the speed it had immediately before hitting the ground. So, immediately before hitting the ground, let's suppose it has a speed of v, that is immediately before hitting the ground, and after it rebounds, it has half the speed. That means immediately before hitting the ground, let's suppose it has a speed of v, and after it rebounds, it has a speed of v by 2. So, when it hits the ground, it has a speed of v. Then, if it rebounds, then it has a speed of v by 2. So find the height above the ground at which P and Q next collide. So we need to find the height at which next collision occurs. So first of all, so initially we saw that P, a particle that is moving upward with a speed of 25 meter per second. So P is moving upward with a speed of 25 meter per second, and at the topmost point it has a speed of 15 meter per second at 20-meter height. So at 20-meter height, that is given that at 20-meter height, it has a speed of 15 meter per second. So initially it is moving at 25 meter per second. Initial speed is 25 meter per second. Then at 20-meter height, it has a speed of 15 meter per second. And at 20-meter height, it collides with Q, which is moving downward with 20 meter per second. So P is initially has a speed of 25 meter per second. At 20-meter height, it collides with Q with a speed of 15 meter per second, and Q is moving downward with 20 meter per second. And after the collision, we saw that P is brought to instantaneous rest. So after the collision, P is brought to instantaneous rest, and Q is moving upward with 10 meter per second. That we have found that after the collision, Q is moving upward with 10 meter per second. So initially, P is moving upward at 25 meter per second. At 20 meter height, it collides with Q, where P is moving at 50 meter per second and Q is moving downward at 20 meter per second. Then, after the collision, P comes to instantaneous rest and Q is moving upward with 10 meter per second. Now, P comes to instantaneous rest, and after it comes to instantaneous rest, P then again moves downward, and as it moves downward, it reaches the ground with a speed of v, and as it rebounds, it has a speed of v by 2. Now we need to find height above the ground at which next collision between P and Q occurs. So first of all, what is this speed v? What is this speed v when it reaches the ground? So v square minus u square is equal to 2s. So v square is equal to 2as plus u square. So 2, and acceleration due to gravity is 10 meter per second square. So 10, and the distance is 20 meters. So the distance here we can see that it is 20 meter, and the initial speed, that is initially at rest, so the initial speed is 0. So we find the value of v, that is 20 meter per second, or negative 20, and negative 20 is not the answer, or inadmissible or not acceptable. So when it reaches the ground, it has a speed of v, and v has a value of 20 meter per second. So as it rebounds, it has a speed of v by 2, that is 20 by 2, that is 10 meter per second. So it rebounds with a speed of 10 meter per second. So now here we can see that P rebounds with a speed of 10 meter per second. That is v by 2, that is 10 meter per second. P moves upward with a speed of 10 meter per second. Now, as P moves upward, so what time does P took to reach from the 20 meter to this point? That is 20 meter from the height of 20 meter to the ground. So what is the time interval for P to reach the ground? So time for P to move to the ground. So time for P to move to the ground, that is from the initial rest to the ground, what is the time? So V is equal to U plus AT, and we have found that the final speed when it reaches the ground is 20 meter per second, that is 20 meter per second, and initially it is at rest, that is initial speed is 0. So initially it is at rest, plus acceleration is 10 meter per second square, and the time for P to reach the ground. So this is the time for P to reach the ground. So P took about 2 seconds to reach the ground. So P took about 2 seconds to reach the ground. So 2 seconds. Now, so P took 2 seconds to reach from the 20 meter to the ground. Now, what is the distance traveled by Q? So what is the distance traveled by Q? So first of all, to find the value of distance, S is equal to ut plus half at square. So by using the to use the formula, what is the time for P to travel? So you have to remember that when P reaches from the topmost point, that is above 20 meter to the ground, it took 2 seconds. So when Q is moving upward, it took 2 seconds plus an extra time t, which is the time of collision. So this is the time t at time of collision. That is the next collision between P and Q. So this t is the time for the next collision between P and Q. So this is the time t for the next collision between P and Q, and 2 seconds is for P to reach the ground. So Q is moving upward with a time of 2 seconds. So this 2 seconds is the time for P to reach the ground plus an additional time t for the time of collision. So the time for Q, that is 2 seconds for 2 seconds. This time is for P to reach the ground. So when P reaches the ground, Q is obviously moving upward. So it is moving upward for 2 seconds. Then for time t, this time is the next collision between P and Q. Next collision between P and Q. So the time for Q is 2 plus t. So the distance Q, S is equal to ut. So what is the initial speed for Q? So initially it is moving upward with 10 meter per second. So initially, here we can see that Q is moving upward with 10 meter per second after the collision. So ut plus half acceleration is negative 10. Why the acceleration is negative 10? Because as it moves upward, the acceleration would be negative, but if it is moving downward, then acceleration is positive. So since Q is moving upward, so the acceleration is minus 10, 2 plus t square. So this is the distance traveled by Q, that is SQ is this value. So this is the distance traveled by Q before collision. Now what is the distance traveled by P before collision? So P has already traveled 2 seconds. That is 2 seconds to reach the ground. So P has already traveled 2 seconds to reach the ground. 2 seconds to reach the ground. So P has already traveled 2 seconds to reach the ground. So it has already traveled 2 seconds. Now it have to travel t second for the time of collision. So now it have to travel t second for the time of collision for P. So time for P is t second for the next collision. So time for P is t second for the next collision. So the time is t. So S is equal SP is equal to ut plus half a t square, and P has the initial speed. So what is the initial speed of P? So what is the initial speed of P? So P from the 20 meter height took 2 seconds to reach the ground. Then after reaching the ground, it has a speed that is divided by 2. So 20 divided by 2, that is 10 meter per second. So it is moving upward with 10 meter per second. That is the initial speed is 10 meter per second. And the time is t for the next collision. So ut plus half, and since it is moving upward, so for movement upward, the acceleration is negative, half a t square. So this is the distance traveled by P, and this is the distance traveled by Q. So distance P and distance Q. Now, here we can see that as the objects collide, SP is equal to SQ plus 20. Why SP is equal to SQ plus 20? Because here we can see that initially P is at the ground, while Q is 20 meter above the ground. So P is at the ground, while Q is 20 meter above the ground. So P have to travel this 20 meter plus the distance traveled by Q. So P have to travel, that is SP, have to travel this 20 meter plus the distance traveled by Q, that is SQ. So SP is equal to 20 meter, that is 20. So this 20 meter, that is 20 meter. So SP is equal to 20 meter plus the distance traveled by Q. So SP is equal to 20 meter, that is the difference in height plus the additional distance traveled by Q. So SP, that is SP is equal to 20 meter plus the distance traveled by Q, So if we equate this, we find the value of time, that is 1 second. So the next collision occurs when time t is equal to 1 second. So now the next collision occurs when time t is equal to 1 second, that is 1 second. Now find the height above the ground. So the find the height above the ground. So you have to remember that the height above the ground. So what is the height above the ground? Now, here we can see that Q is already 20 meter above the ground, but P is from the ground. So since P is from the ground, so we need to substitute the value of time in the equation of P to find the height above the ground, because P is at the ground while Q is above the ground, and we need to find the value of height from the ground. Since we need to find the height from the ground, so we have to use the distance equation from P, because P is at the ground while Q is 20 meter above the ground. So we have to use the equation for P to find the value of distance, that is 5 meter. So the next collision occurs at a height of 5 meter above the ground. So the next collision occurs at a height of 5 meter above the ground. So above the ground. Now again, if we just recall, initially P is moving upward at 25 meter per second, then at 20 meter height, P collides with Q. So P at this time has a speed of 15 meter per second and Q has a speed of 20 meter per second. Now as the collision between P and Q occurs, so P comes to momentary rest or instantaneous rest, and Q is moving upward with 10 meter per second. Now as P comes to rest, then again P moves downward. So P moves downward, and when it reaches the ground, it has a speed of V. Now as P rebounds, it has a speed of V by 2. So as P rebounds, it has a speed of V by 2. So what is the speed when it reaches the ground? So speed of P when it reaches the ground, so V square minus U square is equal to 2s. So V is the final speed when P reaches the ground, and U is the initial speed, that we can see that initial speed is 0, that is it is initially at rest, is equal to 2 as. And since P is moving downward, so the acceleration is positive. So after substituting the value, we find the value of V, that is 20 meter per second, and negative 20 meter per second. So negative 20 is not the answer or inadmissible. And when it P reaches the ground, it has a speed of 20 meter per second. And as we can see that when it rebounds, it has a speed that is half. Since it has half the speed, so initially when it hits the ground, it has a speed of 20 meter per second. So when it rebounds, it has a half the speed, that is 20 by 2, that is 10 meter per second. So now it moves upward with 10 meter per second. So P moves upward with a speed of 10 meter per second for P. Now, time for P to reach the ground. So what is the value of time for P to reach the ground? So first of all, from the topmost point to the bottom point, what is the time for P to reach the ground? So to find the value of time, we can use the formula V is equal to U plus AT, where we know that the final speed when it reaches the ground. So final speed when it reaches the ground and not when it rebounds. So when it reaches the ground, it has a speed of 20 meter per second. So V is equal to U, and the initial speed is 0 meter per second. So V is equal to U plus acceleration, since it is moving downward. So the acceleration is positive. So after substituting the value, we find the value of time for P to reach the ground. So time for P from 20 meter height to the ground is 2 seconds. So 2 seconds, P took about 2 seconds to reach the ground from the 20 meter height. Now we refer the time t in these equations at the time of collision. T is the time of collision. So for Q, what is the total time for the time of collision? So what is the total time for Q before the collision? So time for Q before the collision. So here we can see that when P moves from this side to this side, so when P moves from the topmost point, that is 20 meter height, to the ground, so when P is moving, Q is also moving upward. So since Q is also moving upward, so Q also moves 2 seconds. So since P took 2 seconds to reach the ground, so Q also moves to this 2 seconds, and in extra time T, that is the time of collision. So Q moves upward 2 seconds, that is that P travels to reach the ground, that is 2 seconds, and extra time T at the time of collision. So Q have to travel 2 seconds. This 2 seconds is the time for P to reach the ground. So time for P to reach the ground, and for this 2 seconds, Q is also moving upward. So Q have to travel 2 seconds plus extra time T for the time of collision. So the displacement of Q is S is equal to ut plus half at square, and from the equation we can see that, or from the given information we can see that Q is moving upward with 10 meter per second. So the initial speed is 10 meter per second, and the total time that we have found before collision is 2 plus t plus half. Acceleration is negative since Q is moving upward, so acceleration is negative a t square. So after substituting the value, we find the displacement for Q. Now what is the displacement for P? So displacement for P. Now for Q, we have found the time, that is 2 plus t, and 2 is the time for P to reach the ground. So P has already reached the ground, and we have to find the displacement for P from the ground. Since it has already reached the ground, so it has already traveled this 2 seconds. So we don't need this 2 seconds right now, and P now have to travel this time t second for the time of collision. So from the ground, it have to travel time t for the time of collision. So Sp is equal to ut plus half a t square. So initially it has a speed of 10 meter per second at the ground. Ut, this t is the time of collision plus half a t square. So after substituting the value, and since it is moving upward, so the acceleration is negative, we find the displacement for P. Now, as the objects collide, displacement of P is equal to the displacement of Q plus 20. Now, why the displacement of P is equal to displacement of Q plus 20? Because as we can see that initially P is at the ground, but Q is already 20 meter above the ground. So Q is already 20 meter above the ground. Now, displacement of Q for the two objects to collide, P have to travel this 20 meter, P have to travel this 20 meter, and additional distance, that is SQ, that is traveled by Q. So P have to travel this 20 meter plus the additional distance traveled by Q. So SP is equal to SQ plus this 20 meter, because P have to travel from this point to this 20 meter plus the additional distance traveled by Q. So after equating that, the value, that is equation for P, that is this value, is equal to equation for Q, that is displacement for Q plus 20. So after equating this, we find the time. Now as we find the value of time, now we need to find the height above the ground. So we need to find the height from the ground. But as we can see that Q is already 20 meter above the ground. Since Q is already 20 meter above the ground, but we need to find the height from the ground. So we have to find the displacement for P, because P moves from the ground. Since it moves from the ground, so we can use the equation for P, because it moves from the ground. So after substituting the value of time in the equation for P, we find the displacement, that is the distance or the height above the ground. So we find the height above the ground at the where P and Q collide. So by substituting the value of time in the equation for P, because P moves from the ground, only P moves from the ground, while Q moves 20 meter above the ground. But for P, it is moving from the ground. So after substituting the value of time in the equation for P, we find the height above the ground at which P and Q next collide. That is height above the ground at which P and Q next collide.